Hello, in this video I would like to explain the concept of the unit circle. So why the unit circle is so popular when we need to find the values of the trigonometric functions, especially if we're talking about the exact values. So let's recall that definition of sine, cosine, tangent, and cotangent. So if you have a right triangle and say any of these acute angles we can call theta, so and the legs over right triangle without any attachment, so you can say A and B, you can say opposite leg, adjacent, and the hypotenuse. So the ratio, so we know that the ratio of the sides of all right triangles with the same angle theta will remain the same. What is here? Say the ratio A to hypotenuse will be the same if we extend or reduce this triangle. So the triangle like so, the triangle like so, they all will have the similar triangles, they all will have the same ratio. And this ratio, they're adjacent to the angle side to hypotenuse, we call cosine, cosine of angle theta. And then the opposite side to hypotenuse, we call opposite side, we call sine theta. That's second ratio. The ratio of opposite leg to adjacent leg, we call tangent theta. And the ratio adjacent leg to opposite leg we call cotangent theta. Also, there are two more. The reciprocal C over A for cosine, it's secant, and the reciprocal for of the sine, and that is cosecant. So let's go ahead and look at how we can apply this to the idea of unit circle. So if we have a unit circle, the radius of this circle is 1, and it's convenient for us just to learn about the angle pi over 6 or 30-degree angle, the angle pi over 4 or 45-degree angle, and the angle pi over 3 of 60-degree angle. So what is interesting that when you have a unit circle and you look at the triangles formed here, you will see that the hypotenuse for all these three triangles, if I kind of slightly draw here, so these right triangles that form, they all have hypotenuse of 1, and that's what we will get division by 1, or for a unit circle, basically the adjacent side is x coordinate and the opposite side is the y coordinate. So that's why we say that for unit circle, sine of any angle is y coordinate. For unit circle, if the point is on the unit circle here. And we found the coordinates of this point for angle pi over 6, the point on the unit circle and on the terminal side of angle pi over 6. What are these coordinates? The coordinates are square root of 3 over 2 for x and 1/2. For the angle pi over 4, the point that is a point where this terminal side crosses over the unit circle, will have coordinate square root of 2 over 2 and square root of 2 over 2. And their point here for pi over 3 angle will be square the y coordinate square root of 3 over 2, the x coordinate 1/2. So basically, again, it's another thing to remember easier, that these two have the same numbers but in a different order. And if you look at the pi over 6, this angle kind of creates a triangle which has longer x, and square root of 3 over 2 is longer than 1/2. So that's why this one is square root of 3 over 2, and this one is y coordinate longer than the x, and that's why we figure out. That's kind of a hint how you can remember. So like I said, in general, for a triangle, a cosine is ratio of adjacent to hypotenuse, but the hypotenuse is 1. So for us, with the unit circle, cosine of pi over 6, because it's adjacent portion here, or square root of 3 over 2. And sine pi over 6, look, it's opposite leg, right? Opposite over hypotenuse. Opposite is the shorter leg for this angle, which is 1/2. And so on. This idea you can apply to all three angles. Also, you can apply to so-called quadrantal angle. Say this is angle 0. And as you can see, cosine 0 is 1 because x coordinate is 1, and sine 0 is 0 because the y coordinate is 0. At the same time, this angle is pi over 2, or 90-degree angle. This is the terminal side, this is the initial side, and the point here has coordinate 0, 1. That's why cosine pi over 2 is 0, sine pi over 2 is 1. But how to extend this into, say, quadrant 2, 3, and 4? The idea is that we use these angles, we call them acute angles, pi over 6, pi over 4, pi over 3, as reference angle. So for instance, what example can we have here? Say we need to find the angle, the cosine 5 pi over 6. So the angle 5 pi over 6, so it's less than pi because it's 5/6 over pi, right? So it's less than pi, so it will be over here in the positive direction, as you remember, this way. So we're missing here pi over 6. So this angle in light green color is angle pi over 6. As you can see, 5 pi over 6 plus pi over 6 gives you pi. So what is interesting that these 2 points over here and here are symmetric with respect to the y-axis. They have the same y coordinate, so for that we can say sine pi over 6 if we would need to find sine pi over 6. Sine pi over 6, because we see it clearly here on this picture. Here's the sine, and it will be 1/2. But what is about cosine 5 pi over 6? Cosine is adjacent. Adjacent to this angle is this side. So the cosine will be negative cosine pi over 6 because it's symmetric but on the opposite sides of y-axis, so it will be negative square root of 3 over 2. And that's how you can apply. So you need to memorize just these angles. Another example. Let me open something new. And let's say we need to find sine 5 pi over 3. So what is 5 pi over 3? It is, if it was 6 pi over 3, it will be 2 pi angle. So first let's find this angle. So I have my angle. So I'm going 5 pi over 3. So if I divide 3 into 5, it will be 1. So I'll go 1 pi and remainder 2 pi over 3. So I'm here. And the terminal side of this angle is here. So this angle is 5 pi over 3. Now what is the reference angle? The reference angle is acute angle, pi over 3. So I can see that if I draw a unit circle, this one, and have here my angle pi over 3, and I have angle 5 pi over 3, they have symmetry with respect to the x-axis, which makes their x-axis here, these points, have the same x-axis, but opposite y. Here y positive, here y negative. Sine we associate with the y-coordinate, it for sine pi over 3 it will be positive value. For sine 5 pi over 3 it will be negative y. So we say negative sine pi over 3. And what is sine pi over 3? Negative square root of 3 over 2 is the answer. First, let's see where is the angle. The angle 5 pi over 4, if you divide 4 into 5, you get 1 pi plus pi over 4. And it tells you how to graph the angle. Let me erase this a little bit. And the graph with the unit circle will look like so. So we're going 1 pi and then additional pi over 4. So this is the terminal side. So what is this reference angle? Pi over 4. What is tangent pi over 4? Tangent pi over 4 is sine pi over 4 over cosine, or y over x coordinates if we're talking about the unit circle. But the coordinates are the same, square root of 2 over 2 for y for pi over 4 and square root of 2 over 2 for x, which is 1. Now what is here? What are these third quadrant? The x coordinate will be negative, the y coordinate negative, so the entire tangent will be positive. And we need to keep in mind the sign as well. So the tangent will be positive because it's ratio y to x. Y is negative, x is negative for this third quadrant. When you divide negative by negative, you get positive result. So tangent 5 pi over 4 equals positive 1. Because in absolute value, the tangent 5 pi over 4 equals tangent pi over 4, and in sign is the same.